Today's topic of my presentation is transformers. I will explain its definition, types, uses, construction, and maintenance. Main contents of this presentation are: Introduction to transformers, types of transformers, transformer construction, working principle of transformers, transformer losses and efficiency, transformer testing and maintenance. A transformer is a device used in the power transmission of electric energy. The transmission current is AC. It is commonly used to increase or decrease the supply voltage without a change in the frequency of AC between circuits. A transformer is a static device, means that has no moving parts, that consists of one, two or more windings which are magnetically coupled and electrically separated with or without a magnetic core. It transfers the electrical energy from one circuit to the other by electromagnetic induction principle. There are several types of transformers. Here are some of them. Step-up transformers, step-down transformers, power transformers, distribution transformers, isolation transformers, autotransformers, current transformers, potential transformers. A step-up transformer is an electrical device that converts low voltage and high current input to high voltage and low current output. It does this by creating a changing magnetic field in the iron core that induces an AC current in the secondary coil with more turns of wires than the primary coil. A step-up transformer is different from a step-down transformer, which does the opposite. A step-up transformer is a crucial component of any electrical system and is commonly used for domestic consumption. Here are some applications of step-up transformers. These transformers are used in electronic equipment such as inverters and voltage stabilizers for low to high voltage stability. It is used to distribute electrical energy. This transformer is used to change the high voltage in power transmission lines generated by generators. This transformer is also used to make electric motors running, X-ray machines, microwave ovens, etc. A step-down transformer is a type of transformer that converts the high voltage, HV, and low current from the primary side of the transformer to the low voltage, LV, and high current value on the secondary side of the transformer. The reverse of this is known as a step-up transformer. Here are some examples of step-down transformers. Electronic SMPS, rectifiers and power adapters, power transmission lines, welding machines, inverters, voltage stabilizers. A power transformer is a device that transfers electric energy from one circuit to another without changing the frequency. It is a static device with no moving or rotating components. Transformers operate on an AC supply and work based on the principle of mutual induction. They can increase, step up, or decrease, step down, voltage. Transformers change voltage through electromagnetic induction, where the magnetic lines of force build up and collapse with the changes in current passing through the primary coil, inducing current in another coil, called the secondary. Power transformers are widely used to step up and step down voltages at the electrical power generating station and distribution station, respectively. They are used in electric power generation and distribution. They are also used for reducing power losses during electric power transmission. They are preferred in cases where the load is required to run at full capacity 24/7. It is used in high voltage step-up and step-down. A distribution transformer is a transformer that provides the final voltage transformation in the electric power distribution system, stepping down the voltage used in the distribution lines to the level used by the customer. Distribution transformers are used for converting high-voltage electricity to lower voltage levels acceptable for use in homes and businesses. The main function of this transformer is to alter the high voltage to the normal voltage like 240/120 V to use in electric power distribution. Here are some types of distribution transformers. Single phase, 3 phases, pad mounted, pole mounted, underground transformers. An isolation transformer is a transformer used to transfer electrical power from a source of alternating current, AC, power to some equipment or device while isolating the powered device from the power source, usually for safety reasons. The main function of this transformer is to isolate the primary and secondary circuits from each other. Here are some examples of isolation transformers. For transformers in a minute dual inline chip package that are used to isolate high-frequency low-voltage pulse circuits. Austin transformer for the power supply of air traffic obstacle warning lamps on radio antenna masts. Low voltage, 3.3 to 24 V, isolated DC-DC power supplies up to 7.2 watts. Low noise RS for 85, RS for 22, and RS 232 isolated serial communications data interfaces. An autotransformer is an electrical transformer with only one winding. The auto prefix refers to the single coil acting alone, not to any kind of automatic mechanism. In an autotransformer, portions of the same winding act as both the primary winding and secondary winding sides of the transformer. Autotransformers are used to adjust the supply voltage when isolation from the line is not necessary. Autotransformers are used for various applications such as starting induction motors, voltage regulation, laboratory purposes, compensation of the voltage drop in the distribution transformers, starting induction and synchronous motors, and many industrial applications like paper mills and factories. Autotransformers are frequently used in power applications to interconnect systems operating at different voltage classes. A current transformer is a type of transformer that is used to reduce or multiply an alternating current, AC. It produces a current in its secondary which is proportional to the current in its primary. Current transformers are also called instrument transformers because they provide a convenient way of safely monitoring and measuring the actual electrical current flowing in an AC transmission line using a standard ammeter. Current transformers are used in various applications such as power monitoring, protection relays, and energy management systems. They are also used in electrical power transmission and distribution systems to measure the current flowing in the lines. Potential transformers are also called voltage transformers. They are used to measure the voltage in an electrical power transmission and distribution system. They are also used in power monitoring, protection relays, and energy management systems. There are three primary types of potential transformers: PT electromagnetic, capacitor, and optical. The electromagnetic potential transformer is a wire-wound transformer. The capacitor voltage transformer, CVT, uses a capacitance potential divider and is used at higher voltages due to a lower cost than an electromagnetic PT. A potential transformer, also known as voltage transformer, is a type of instrument transformer. It is a step-down voltage transformer that reduces the high-level voltage to safer low levels. The output voltage of the potential transformer can be measured by connecting an ordinary voltmeter. A transformer is a static device, means that has no moving parts, that consists of one, two or more windings which are magnetically coupled and electrically separated with or without a magnetic core. It transfers the electrical energy from one circuit to the other by electromagnetic induction principle. The transformer construction consists of two coils of wire wound on a common iron core. The two coils are electrically isolated but magnetically linked. The primary coil is connected to the input voltage source and the secondary coil is connected to the output load. When an AC voltage is applied to the primary coil, it produces a magnetic field around it. This magnetic field induces a voltage in the secondary coil due to electromagnetic induction principle. The working principle of a transformer is based on the principle of mutual inductance between two coils which are magnetic coupled. When an alternating voltage is applied to the primary winding of the transformer, an alternating flux Φm, which is called as the mutual flux, is produced in the core. This mutual flux links with both primary and secondary windings. According to Faraday's law of electromagnetic induction, when a change takes place in the magnetic flux which is linked with a circuit, an electromotive force current will induce in the circuit. This induced EMF will be proportional to the rate of change of magnetic flux linkage. Transformers have losses that reduce their efficiency. These losses are due to the resistance of the windings, load loss, and magnetic effects primarily attributable to the core, iron loss. An ideal transformer would have no losses and would be 100% efficient. The maximum efficiency of a transformer occurs when the copper losses are equal to the core losses. The efficiency of a transformer can be calculated using the formula. Efficiency equals output power, losses, input power. Equals 1, losses, input power. There are two main types of transformer losses. Copper losses. Core or iron losses. Copper losses in a transformer are the heat produced by electrical currents in the conductors of transformer windings. It is proportional to the square of the current flowing through the winding. Copper loss occurs when current passes through the transformer's windings, causing resistance in the wire itself and resulting in heat generation. When the load on the transformer is increased, the copper loss varies because of the increased current and increased resistance caused by temperature rise. Iron loss in a transformer is the power absorbed by the core of a transformer due to eddy currents and hysteresis. Eddy currents are induced by the alternating flux in the core, causing heat dissipation. Hysteresis is the lagging of the magnetic field behind the magnetizing force, causing energy loss. Iron loss is also known as core loss and depends on the magnetic properties of the core material. Iron loss remains the same during no load and full load. Transformer testing and maintenance is an important aspect of ensuring the longevity and reliability of transformers. A power transformer requires various routine maintenance tasks including measurement and testing of different parameters of the transformer. There are two main types of maintenance of transformer. We perform one group on a routine basis, known as preventative maintenance, and the second group on an ad hoc basis, i.e. ACE required. That means for getting smooth performance from a transformer we have to perform some maintenance actions on a regular basis. Here are some resources that can help you learn more about transformer testing and maintenance. Thanks for watching. That is all for today's video on transformers. I hope you found it useful and interesting. I welcome your suggestions in comment box on what topic you want me to cover. If you want to see more videos like this, please subscribe my channel and click the bell icon to get notified whenever I upload a new video. Never forget to like and share.